Hi everyone, welcome to today's webinar. My name's Neve Craven and I am part of the survey and construction team at Copters. So today I'm going to be running through everything related to survey and construction and using drones. We'll run through the best types of drones for survey and construction. We'll run through the two main types of data collection, so photogrammetry and LiDAR, and also run through some data sets so you know what type of thing you can expect to see when using drones within this industry. So jumping straight in, how are drones used within survey and construction? Starting with surveying and mapping. They're used for topographical surveys, so this is high-resolution aerial images for generating accurate maps and 3D terrain models, so it's faster and cheaper than traditional land surveying. Photogrammetry, so detailed 3D models and orthomosaic maps by stitching together overlapping drone images. And then LiDAR surveys, so penetrating that vegetation, mapping bare earth surfaces, and it's perfect for forested and uneven terrain. Then construction, we've got site planning and design. So current site conditions, this will help architects and engineers plan layouts and visualize projects. We've got progress monitoring, so conducting regular flights to track construction progress, comparing against plans, and then keeping stakeholders updated. We've then got stockpile measurements, so calculating volumes of materials like gravel, sand or dirt, and this is using 3D drone data to do so. Quality control, so spotting issues early on, such as structural misalignments, safety hazards or incomplete work. And then for inspection and maintenance purposes, so inspecting them hard to reach areas like roofs, bridges, towers or scaffolding without putting workers at risk. Then lastly, we've got operational efficiency. So this can be for logistics and planning to improve workflow by identifying the bottlenecks early on in materials movement or site access routes. And then for safety monitoring, so ensuring compliance with safety protocols by identifying hazardous areas or unsafe practices from the air. So then how is photogrammetry used in construction? We'll start off with how it works. So photogrammetry captures overlapping images of an area from multiple different angles using drones or cameras. Then it uses software to process these images to extract depth and spatial data. So it generates 3D models, point clouds, orthomosaic maps and contour lines. You can use ground control points or RTK for georeferencing and improved accuracy. And then these outputs can be exported into CAD or BIM software for further analysis and integration. So then how is it used in construction? Starting off with site mapping and analysis, it can quickly create accurate 3D maps and 3D models of job sites before, during and after construction. It can be used for pre-construction planning, so analyse the terrain, elevation and site features to assist in design and layout planning. And then for earthworks and grading verification, so compare as-built terrain models against the design specifications to ensure proper grading. Then for progress monitoring, you can conduct frequent site scans to monitor progress, document any changes and maintain a visual timeline. Stockpile volume calculations. You can use the 3D models to calculate material volumes, such as sand and gravel, as I mentioned earlier, for inventory management. And then for as-built documentation, so you can create precise records of the finished project for future reference, inspections or renovations. And then lastly for clash detection, so you can overlay 3D models into design plans to identify any potential conflicts or deviations early on. Moving on to the second type of data collection, LiDAR. How does this work? It works very differently to photogrammetry. So LiDAR is light detection and ranging. So it uses laser pulses to measure distances. So a LiDAR sensor will emit thousands of LiDAR beams per second towards the ground, and it essentially measures the time it takes for each laser to bounce back to create a point cloud 3D model of the surface. Why you would use LiDAR over photogrammetry is because it can penetrate that vegetation, so that makes it ideal for mapping under trees or bushes. And then it produces high resolution elevation data with centimetre level accuracy, and you can combine LiDAR with GNSS or GPS and IMUs for accurate geolocations. So then how is LiDAR being used within construction? It's being used for topographic mapping, so creating accurate digital terrain models, DTMs, and digital surface models, DSMs, even in them complex or vegetated areas. It's used for earthwork planning and monitoring, so measure cut and fill volumes and ensure grading and excavation match the design specs. And then site analysis, quickly assess slopes, drainage or elevation changes for better planning and risk management. As-built verification, so you can compare actual conditions to design models to spot deviations or construction errors early on. Structural inspections, so generate precise 3D models of buildings, bridges and other infrastructure for inspection or maintenance planning. Utility and infrastructure modelling, you can map underground utilities, roadworks or large facilities with high accuracy for integration with BIM systems. So this is particularly true when you're using SLAM LiDAR. And then clash detection and planning, you can detect spatial conflicts between the planned and existing features or utilities. So now we've run through the two main types of data collection and how they are both being used, we'll jump into the specific drones and sensors that you would use within surveying construction. So starting with the Matrice for Enterprise, it's the best entry-level survey grade drone, and how it's being used within surveying construction is it's being used for aerial photogrammetry. So it captures high-resolution images from multiple different angles to create the 3D models or orthomosaic maps, topographical surveys, and it's ideal for site planning and progress tracking and cut and fill analysis. It's being used for progress monitoring and documentation, so you can perform routine site scans to document phases of construction over time and create visual and data-rich audit trail for stakeholders and compliance. And then it's been used for asset and infrastructure inspection, so you can inspect hard-to-reach structures like roofs, towers, cranes and scaffolding with the high zoom capability or the thermal sensors, and there's no need for scaffolding or any need for risk to workers. So why is it being used? Key benefits of the Matrice for Enterprise. It's got extreme accuracy because it supports RTK positioning for centimetre level accuracy, especially when used for surveying purposes. It's got a 45-minute flight time, so you can cover more area in fewer flights. It's safe and efficient, so the M4E on average saves 75% of time on site compared to traditional methods, and it automates risky tasks, reduces man hours on site and increases worker safety. So in short, the M4E is used because it saves time, reduces costs and increases accuracy, whilst also bringing flexibility to them complex surveying and construction tasks, all whilst keeping the boots off the ground when possible. Then we've got a couple of data sets. So this shows exactly how data from the Matrice for Enterprise is being used. So the Matrice for Enterprise can be used for buildings, especially with the 3D Smart Capture, which was a new function that came with the Matrice for Enterprise. So essentially how it works is you will fly to begin with at around 50 metres, capture around 200 to 300 images, which will then create a base point cloud in the controller. From there, it will then create a spiral flight path around the building to where you'll put in the GSD you want to achieve, which will then calculate the speed and the distance from the building that you need to fly. Once it's done that, you'll then put it into DJI Terra to produce a 3D model like this. So once you've got the 3D model, you can use it for taking measurements, you can put it into CAD, so you can see that on the right hand side here. But then you can also inspect the images for inspection purposes, and in just a moment it'll show you the spiral flight path around the building that the drone did, so you can see that there. Once you've done that base point cloud with the 3D Smart Capture function, it will automatically create this flight route to achieve the GSD that you want to achieve. Then you can interpret the data in things like CAD and GIS afterwards. Then moving on to the Anzu Robotics Raptor. So this is a secure NDAA compliant survey grade drone. How is it being used within surveying construction? It's being used for aerial mapping and photogrammetry. So it flies autonomous grid or waypoint missions to capture data for 2D orthomosaics, 3D models and contour maps. And it's used for site planning, design, validation and land development assessments. It can be used for construction progress monitoring, so doing them repeatable flight paths for progress tracking, visual documentation and stakeholder updates, and it helps identify any delays or any discrepancies early on. Can be used for infrastructure inspection, so it's equipped with a high-resolution zoom camera to inspect roofs, facades, towers and structures without scaffolding or lift equipment, which is ideal for capturing fine details safely and efficiently. It's used for volumetric surveys, so capturing data for cut and fill calculations, stockpile volumes and earthwork monitoring. And then site safety and surveillance, it can be used for aerial overwatch, site security and worker safety assessments. Why is it being used? So it's got the high quality camera system, so up to 48 megapixel stills and 4K video. It's clear, accurate visual data for mapping and inspection. It's got mission planning automation, so it supports automated survey routes, grid patterns and return to home functions, so that means you can do reliable and repeatable missions. It's compact and agile, so it's portable and fast to deploy, so it's great for on-site mobility and rapid assessments. But the main one for this is the data security focus. So it has US-based data infrastructure and NDAA compliant components, making it suitable for government and enterprise use, especially for them military sites or critical infrastructure that are now banning Chinese products from being used on site. And then you've got that optional RTK module to deliver the centimetre level accuracy that you need when doing photogrammetry and you need survey results. The Anzu Raptor is a versatile, secure and survey-ready drone built for professionals within construction, surveying and infrastructure, and it has solid imaging, mission automation and US-based data handling. Sorry, that one's a bit of a mouthful. Making it an excellent choice for companies who want dependable results without compromise on compliance or performance. So if you can use Chinese products but you still need the data quality, this would be the drone that you would go for. Then moving on to DJI's flagship drone, the Matrice 350 RTK. How is this being used within surveying construction? It's used for high precision aerial surveying, so it's equipped with RTK positioning for centimetre level accuracy, which is ideal for topographical mapping, boundary surveys and digital elevation models, DEMs. You can put multiple different payloads on it, but one of them is the P1, so for photogrammetry missions. It can fly autonomous mapping routes using waypoints and grid patterns, so it's capturing high resolution images for generating them 3D models, orthos or contour maps. So it's often paired with the P1 for these large areas, high accuracy photogrammetric results. Then it can be used for LiDAR scanning, so when it's fitted with the Zenmuse L2, it collects dense, accurate point clouds, even through vegetation, so it's used for terrain modelling, cut and fill calculations and as-built documentation. And it can be used for construction progress monitoring, the same as the previous two. You can capture repeatable flight paths for progress tracking over time, which then allows stakeholders to visualise changes, detect delays or document any milestones. And then it can be used for inspection and safety monitoring as well. So you can use zoom or thermal payloads like the H30T to inspect cranes, scaffolding, roofs and electrical systems safely from the air instead of sending in people. Why is it being used? So it's got the RTK enableization. It's also got a modular payload system, so it supports a range of different payloads. We'll go through a few in just a moment, but you can use the P1 for photogrammetry, L2 for LiDAR, or H30T for thermal and zoom, all interchangeable based on the mission needs, so you don't have to buy multiple different drones for different missions. You can use the same drone and interchange the different payloads. It's got that all-weather performance, so it's IP rated 55, it's got a rugged build and anti-interference tech, so it's reliable even in them harsh environments. It's got a long flight time and range, so you can fly for up to 55 minutes with extended transmission range, so it uses OcuSync 3, and it's got hot swappable batteries, which means you can cover more areas with fewer interruptions. And then it's got the enterprise grade reliability, so it's built for demanding work, redundancy in sensors, GNSS and flight control systems, so this all adds to the safety and the peace of mind. In short, what does all this mean? The Matrice 350 is the workhorse of professional drone operations, so it's delivering the accuracy, durability and flexibility that modern surveying and construction projects demand. Now, this is just the drone, so now we'll jump into the different payloads that can be used with the drone, starting with the Zenmuse P1. So this is the survey grade photogrammetry camera. How is it being used within survey and construction? It's being used for that aerial photogrammetry. We won't jump into again what that means because I feel like we've gone over that quite a few times in this already. It can be used for the large scale mapping. So when mounted on the M350, it covers huge areas quickly because it has a full frame sensor and rapid shooting speed, so it's perfect for infrastructure planning, corridor mapping and development projects. It's when used with the M350, it's integrated with RTK, so it reduces or eliminates the need for GCPs, and it supports real-time GNSS data logging for photogrammetry workflows that demand exact georeferencing. Being used for as-built documentation, so it's used to capture precise site conditions throughout the construction process, making it easier to track the progress and verify the work. And then it's being used for earthworks. Again, we've gone through that quite a few times already, so I don't want to bore you too much. Why is it being used then? So it has a 45 megapixel sensor, so it's more detail with fewer flight lines, so essentially you're getting that mass data collection in a shorter space of time. Because this is double that of the M4E, so it's 45 megapixels, the M4E is 20 megapixels, you can fly at twice the height while still maintaining the same GSD, so you can cover more area while still getting the same results data-wise, so you're getting that efficiency. It's got smart oblique capture, so it automatically captures angled images for more accurate and complete 3D modelling, especially of vertical features like buildings and slopes. You've got that efficient workflow. You can cover up to 3 kilometers squared per flight at a GSD of around 3 centimeters. So you're saving that time and increasing the output per battery cycle. With the P1, it's got interchangeable lenses, so you can choose from a range of lenses to suit the different altitudes, resolutions and project needs. And then it's got seamless integration. It works directly with DJI Terra and third-party photogrammetry softwares like Pix4D, so it's streamlining that data processing. Essentially, the Zenmuse P1 brings together speed, scale and accuracy, making it the go-to payload for high-efficiency survey-grade photogrammetry in demanding construction and surveying environments. Now we'll move on to the Phase 1 P3. Which is the, oh, no we won't. We've got a couple of data sets first to have a look at. So the first one on the left is a site that we've done for calculating the areas. And then the one on the right is one that I did with Canterbury City Council last year. It's a beach. We did this to calculate how much sand is moving. So we did this, and then the following week they would go back and do it again. To see how much sand has moved, how much is still there. So it's doing that progress monitoring of the beaches over time. Now we'll move on to the Phase 1 P3. I was jumping ahead of myself. So the phase 1 is known for capturing the smallest details in the largest areas in the shortest time. So essentially it's an ultra high resolution aerial camera system designed specifically for professional mapping, surveying and inspection. The P3 delivers unmatched image quality and accuracy, which you'll come to see, making it the go-to for demanding geospatial applications. So this is particularly in rail. It's being used a lot there, where you need that quality within the images and the models that you're creating. It integrates with the M350, so it combines the power of drone-based photogrammetry with the full frame clarity and detail. How is it being used then? It's being used for high-resolution aerial mapping. Again, we've been over this, construction progress monitoring, asset and infrastructure inspection. So this is slightly different. It zooms in on roofs, facades, towers and bridges with incredible detail compared to the other solutions that we've looked at today. So it's ideal for detecting hairline cracks, corrosion or structural wear. It's used for BIM and as-built integration. So it generates image data sets that feed directly into BIM models or CAD platforms for precise digital twin creation. And then it's being used for heritage and cultural site surveys. So it's being used for preserving fine architectural detail and generating millimetre accurate records of historic sites. So unlike the previous ones that were the best we're going to achieve is 10mm accuracy, we're looking at millimetre accurate records for historic sites here. So why is the phase 1 being used? It's got that incredible resolution, so you can get up to 120 megapixel resolution from a medium format sensor, so the detail goes far beyond standard drone cameras. It's got high dynamic range, so it captures subtle textures and contrast even in them harsh lighting or shadowed areas, which is crucial for accurate models and inspections. You've got that survey grade accuracy when it's integrated with RTK on the M350, so centimetre level geolocations. Again, like the P1, it's got interchangeable lenses, so it comes with factory calibrated lenses. You can have 35mm, 80mm, or I believe it's 100mm, but don't quote me on that one, it might be 120, for flexibility across project types and altitudes. And then it's efficient data capture. So again, fewer flight lines needed compared to the lower res cameras. So you've got faster missions, less data to process and more area covered. So as I said before with the P1 compared to the M4E, you can fly at twice the height. Again, with the 120 megapixels, that's almost 3 times the height that you can fly with the P1 while still getting the same GSD. So you're covering more area quicker. Essentially, the phase 1 is built for professionals who need that crystal clear survey grade imagery over large or complex sites. It delivers unmatched accuracy, image quality and efficiency. So it's ideal for construction, surveying, inspection and preservation projects where every single detail matters. I've got an example here of it being used on a church tower that we did. So you can see the level of detail that you get in with these models. It can be used for inspection purposes as well as being used to take measurements and things like that. So if you do need that high level of detail, then you would go for the phase 1 P3 over any other sensor that's out there. I'll leave that to play for just a sec. Now moving on to LiDAR sensors for the M350, starting with the L2. It's the precision LiDAR solution from DJI. How is it being used within survey and construction? It's being used for LiDAR-based terrain mapping, so it's capturing dense point clouds that represent the Earth's surface, even through vegetation. So it's being used to create DTMs and DSMs. Being used for topographical surveys, so it's ideal for the complex or vegetated terrain where photogrammetry alone would struggle. So it can be used for scanning forests, slopes, riverbanks or even uneven ground with precision. It's being used for cut and fill earthwork analysis, as-built and infrastructure modelling. Again, we've gone over these ones a couple of times. And then also for corridor mapping, it's great for mapping long linear assets like roads, railways, pipelines and utility corridors with elevation detail where photogrammetry might fail because there's not enough identifying features for it to stitch the images together with. Why is the L2 being used? So you're getting that high point density and accuracy. So up to 240,000 points per second with 5 returns and 3 centimetre level vertical accuracy. You've got an integrated RGB camera, so this adds colour to the point cloud, great for the visual context and classification. It's got high precision IMU, so improved IMU and GNSS and RTK integration, so you're getting that survey grade accuracy. It's fast and efficient, so you can scan large areas quickly, reducing the time needed to be spent in the field while still producing the high resolution models. And it's an all-in-one workflow, so it integrates with the M350 and DJI Terra for smooth mission planning, data collection and processing all in one go. And then obviously vegetation penetration. The LiDAR pulses can reach the bare earth surface through trees and bushes, unlike photogrammetry. One thing to note with the L2 though is that if you've got a tree canopy, it needs to be able to see light on the ground to bounce back from. So if you've got super dense vegetation where there's going to be no light getting through, then it's not going to penetrate that vegetation. There's got to be some light seen on the ground underneath. Essentially, the L2 is a precision LiDAR solution built for surveyors and construction who need reliable, highly accurate terrain and structured data, especially where traditional photogrammetry will fall short. So I've got an example here of a forest that we did with the L2. We can strip back the trees and then we're left with just the ground surface model. So you can see how it penetrates that vegetation. Now moving on to my favourite of all of the sensors that we actually do here at Copters, the Emerson Hovermap STX. So this is the most versatile LiDAR solution on the market. So it can be attached to a drone, it can be attached to a car, it can be walked with a backpack, and it can be handheld. That's why it's my favourite. You can use it for all different types of projects. It doesn't get repetitive. You can use it indoors, outdoors, above ground, below ground. So what is the Hovermap STX? It's a high-end LiDAR scanning system. So it's developed by Emerson and it's designed for mobile 3D mapping. It can, as I mentioned, it can be put on drones, vehicles, and being used handheld or backpack style. And then it uses SLAM, so that's simultaneous localization and mapping. That took a little while to remember. So it uses SLAM tech, meaning it works without GPS, so it can be used indoors or out. And it's a go-to for the complex environments where traditional surveying tools might struggle. So how is it being used within surveying construction? It's being used in them GPS-denied 3D mapping areas, so it can be used in tunnels, basements, indoors and dense forests, where GNSS isn't available, and it's ideal for underground utilities, mining and enclosed infrastructure. It's being used for construction site scans, so it's mounted on a drone or carried on site to generate detailed as-built 3D models. It helps to monitor the structural progress, detect any deviations or compare against design plans. It's being used for digital twin creation, so it generates accurate 3D point clouds for creating digital twins of structures. So this could be from buildings to bridges. And then it's used for infrastructure inspection. So it can be flown around bridges, towers or industrial plants, or flown inside confined space areas to gather a full 3D context. And then again, it can be used for volume or earthworks calculations. Why is it being used? So it's being used because it's got that SLAM-powered autonomy, so it can navigate and map autonomously in areas with no GPS, so indoors, underground or under canopies. It produces ultra-dense point clouds, so it captures up to 1.2 million points per second with survey-grade accuracy, so it's suitable for detailed analysis. As I mentioned, it's got that versatile deployment. It can be mounted on drones, vehicles, backpacks or handheld, so it's one unit with multiple use cases. It's got 360-degree LiDAR coverage, so the rotating LiDAR scanner captures full spherical coverage, so it ensures no blind spots are in the scan. And then it uses real-time data and autonomy, so it's capable of real-time SLAM map visualization, collision avoidance and autonomous flights in complex environments. And then another reason would be the processing software Aura. So it comes with the powerful software tools for refining the data, aligning the scans and generating clean, usable point clouds, which can then be put into CAD or BIM softwares. So essentially, the Hovermap is the go-to tool for when you need survey-grade 3D data in challenging or GPS-denied environments, and it's a top-tier choice for construction, surveyors or engineers working on projects where mobility, autonomy and accuracy are critical. I've got a couple of examples here from when I did a road trip a few months ago with the Hovermap STX. So on the left, we've got a street in Bath that I did. This was done walking with it on the backpack. We colorized the point clouds using the GoPro, but I went up one side of the street, came back down the other, and you can see we have a full 3D model to work with. And then on the right hand side, again, when I was on this road trip, one of my clients I went to see suggested that I walk the Severn Bridge into Wales because I said I'd never been to Wales. So I did it with the backpack on, and you can see that I captured I only did half of the bridge, but you can see that I captured all the fine details of the bridge just by simply walking across with the backpack on. If I wanted to do it underneath the bridge as well, I could have mounted it to a drone and then flown underneath the bridge. Lastly, moving on to a completely different drone to everything else that we've covered today, the Flyability Elios 3. So this is revolutionary for confined space 3D mapping. The Elios 3 is a cutting-edge collision-tolerant indoor drone. So it's equipped with LiDAR and a high-resolution visual inspection camera, and it's designed specifically for confined space inspection and GPS-denied 3D mapping. So it excels where other drones don't, in the places where normal drones like the M4E or the M350 simply could not reach, like tunnels, silos, tanks, crawl spaces or any industrial interiors. It's the ultimate solution for safe and efficient inspections without the need for human entry into those hazardous environments. So how is the Elios 3 being used? It's being used for the confined space inspection. So it flies inside buildings, ducts, tanks, sewers, tunnels and subterranean spaces where GPS doesn't work. So it eliminates the need for scaffolding, confined entry permits or manual inspection. It's being used for as-built and structural documentation. So it captures LiDAR point clouds for creating accurate 3D models of interior spaces, complex structures or existing infrastructure, and it supports digital twin creation and integration with BIM workflows. It's been used for construction verification, so it's used to verify an as-built condition, detect structural issues and validate workmanship in areas that are otherwise hard to access. It's used for underground and tunnel mapping, because it's perfect for sewer systems, utility tunnels and underground infrastructure and underground shafts. And then it's being used for asset integrity and maintenance, so it can visually inspect assets like pipes, beams, walls and machinery for any corrosion, cracking or any other signs of wear and tear. Why is it being used? So similar to the Hovermap STX, it uses SLAM-powered LiDAR mapping. So it then uses this to create real-time 3D maps in GPS-denied environments. It's got that collision-tolerant cage built around it, so it's fully enclosed in a carbon fibre cage, which means it can safely bounce off of surfaces and keep flying in tight or cluttered areas. It's got that high-resolution visual camera, so it's equipped with a 4K camera and thermal imaging for detailed visual inspections. It's safe and efficient, so it reduces or completely eliminates the need for dangerous manual inspections, and it saves time, cost and risk. And then this, again, like the Hovermap coming with Aura, it comes with Inspector 4 software, so you can do the post-processing, allowing people using this to visualise point clouds, annotate any issues, and export these point clouds into CAD or BIM softwares. And then it's got the modular payload bay, so similar to the M350 where you can interchange different payloads based on the mission need. You can do this on the Elios as well, so that can be a radiation detector, a gas detector or UT sensors. Essentially, the Elios 3 is the revolutionary drone for confined space inspection and indoor 3D mapping. It gives construction and surveying teams the ability to digitally access and analyse areas that were previously unreachable, all while keeping boots off the ground. So it's a perfect blend of safety, intelligence and precision. I've got a couple of examples here. Oh, there we go. So the one on the left is a silo that we did using the Elios 3, flew it inside. And then the one on the right, again, was from my road trip. So we did the area in red, we did the culvert with the Elios, flew inside. And then the areas in blue we did with the Hovermap STX, so walked around the top with it on the backpack. We then merged the 2 point clouds together so we could see exactly where the water culvert was underneath the town in Bristol. So that's a perfect example of merging or using 2 different solutions at once to create a 3D model. So essentially, why are drones being used in survey and construction? I hope we all have a better idea now, but it's essentially to reduce time on site, increase the safety of the team, have better documentation of site data and reduce asset downtime. Now, if you do have any questions, please drop me an email. It's neve.craven@copters.com or give me a call. It's 0330 111 7177 and ask for myself, Neve, and we can run through any questions that you've got. I hope today's been helpful and not too long-winded for you all, but I hope you all have a great rest of the day. Bye.